Space, the final frontier, is incredibly vast and breathtakingly beautiful. But it is also a very harsh environment for humans. One of the biggest unseen dangers our astronauts face out there is space radiation. Think of it as a constant shower of tiny high-energy bullets zipping through space at nearly the speed of light. These particles can easily pass through the skin of a spacecraft, and sadly, also through the bodies of the astronauts inside. These energetic particles come from two main sources: our Sun and galactic cosmic rays, GCRs. The Sun sends out a stream of particles called the solar wind, and sometimes it has massive eruptions, like solar flares. GCRs originate from distant events in our galaxy, such as exploding stars, known as supernovae. Short-term exposure to high levels can cause radiation sickness, with symptoms like nausea and fatigue. The real worry for astronauts on long missions like a trip to Mars is the long-term risk. This constant exposure can damage DNA, increasing the risk of cancer later in life. Protecting our explorers from this invisible barrage is essential if we want to push the boundaries of human exploration further into the cosmos. Traditional methods involve using thick layers of materials like aluminum or polyethylene on spacecraft walls. A smarter solution is clearly needed for our future in space. Imagine a shield that isn't just a physical barrier, but a smart, thinking protector. This is the core idea behind NASA's groundbreaking AI-powered radiation shield. Instead of building thicker walls, it's about using artificial intelligence to create a dynamic and responsive system. This system aims to actively monitor the space radiation environment in real time, predict dangerous events, and help the crew take protective actions. Traditional shields are like wearing a heavy suit of armor all the time, even when the threat level is low. This new AI system is more like having an incredibly vigilant lookout who can see danger coming from miles away. It integrates data from various sensors to build a comprehensive picture of the radiation weather. The AI could identify periods of intense solar particle events and advise astronauts to move to a more heavily shielded storm shelter area within the spacecraft. It could also suggest reorienting the spacecraft to use its bulk or existing equipment as temporary extra shielding. The beauty of this AI-driven approach is its adaptability and intelligence. Space is a dynamic environment, and radiation levels can fluctuate dramatically. The AI system learns from past events and current data, anticipating spikes in radiation from solar flares. This proactive capability offers a level of protection that was previously unimaginable.